Hello and welcome to part 3 of the lecture for chapter 21. So I'm going to talk a little bit today on some topics that will build on what we've talked about in the previous 2 lectures. And I want you to please note that I uploaded a video practice for a problem that'll help with the homework that is due on Wednesday evening. So first thing I want to talk about is product mix implications. So product mix is important because the examples we've had up until now, companies have had one single product, but we all know that that's not necessarily realistic, that most companies have more than one product. So I want to talk a little bit about sales mix first, and then we'll get into a couple of other topics, including graphing. So the first thing, sales mix. So here's a company that has $200,000 in fixed cost. They've got product A and product B that have different selling prices and variable costs, and which leads to different unit contribution margins. And they've got different quantities of units sold. They sell, you can see here, far more product A than they do product B. So the first thing we'll do is look at the sales mix. And the sales mix is based on not sales dollars, but on units sold. So it's here you can see they sold a total of 10,000 units, or they anticipated that. And so 80% of their sales are product A and 20% of their sales are product B. So what we want to come up with is a fictional blended unit, which this book calls product E, which stands for enterprise product. So we're going to do a weighted average of information for these two products so that we have a single fictional product that we can calculate break even on, and then we can break it out into the two products after that. So in this case, the selling price of that fictional blended product E is product A's $90 selling price times 0.8 or 80%. Plus product B's selling price of $140 times 20%. So I'm taking a weighted average here and getting $100 as the price of that fictional unit. Okay, I do the same thing for variable costs. So now I come up with a blended fictional unit contribution margin that is based on the information for product A and product B weighted by the mix of those two products. So if I change this mix, if instead it was 60-40 or something, it would very likely change those figures for product E. So now I can take product E and I can do break even just like we did in the previous lecture. So I can take the fixed cost of 200,000, divide by the unit contribution margin of that product E, $25 we just calculated, and I can see that they need to sell 8,000 units in order to break even. I can then take that 8,000 units and say, what is 80% of that? So 80% of 8,000 is 6,400. So they need to sell 6,400 of unit A, and they need to sell 8,000 times 20%, 1,600 of product B in order to break even at that mix. So you've got a homework problem on that, and I'll post a video practice for that tomorrow as well. The next thing I want to talk about is a cost volume profit chart. So how to show this information visually. I have found in my past jobs in different companies that, especially when dealing with people that don't have accounting training or education, that doing things graphically can be more intuitive for them. So the steps in creating this cost volume profit chart are: step 1 is creating the volume in units along the horizontal axis and a line for total sales and total cost on the vertical axis. And that would be done for the relevant range of sales you expect in units. So 0 through what you think your capacity is or likely capacity. The second step is going to be plotting the sales line. That's always going to start at 0 because if you sell 0 products, you have 0 sales. Then I'll take a look and say, what is my selling price per product times the maximum quantity? Get a total sales dollar. I'll plot that point, okay, based on the y-axis, and I'll draw a line between those 2 points. Step 3 is to do a total cost line. The total cost line is going to start, the y-intercept is going to start at the level of fixed cost and then is going to go up at the rate of my variable cost. So I'll calculate what are my total variable cost at my high level of quantity, and then I'll add that to the fixed cost to put another point there and draw a line between those two. Now the point where those two lines intersect is the break-even point. So here's an example where you can see the total sales line starts at 0 and goes up to $500,000. So that's $50 per unit times 10,000 units. They think that 10,000 is their max capacity. So the total cost line, you can say I've got variable cost of $30, so 30 times 10,000 is $30,000. And then it starts at 100,000, so I can plot my point for total cost, or excuse me, $300,000 for variable cost. So 300,000 plus 100,000, it's going to end at 400,000. So I can draw a line between the $100,000 point on the y-axis and 400,000 for my total cost on the far right side. And I can see where those two lines intersect. That's where total sales equal total cost. That happens at 5,000 units. Now, just to check my math for fun, I could look up in the upper right corner there and say, well, I've got a unit contribution margin of $20. I've got fixed cost of 100,000. So how many units that each give me a $20 bill do I need to sell to cover $100,000? 100,000 divided by 20 is 5,000. So I can verify the information in my graph that way. So notice that the area in the dark pink there to the left of the break-even point, the operating loss area, the vertical distance between those two lines is the company's loss at that volume of sales. And then correspondingly to the right side of the break-even point, that green shaded area, the vertical distance between those two lines, is their profit at that given level of unit of sales. So if we altered this and said, well, what if our fixed cost went down to $80,000? How would that change our break-even point? Here we've got that graph where you can see it lowers it to 4,000 units of sales. So again, this is a good way of depicting for people, this is where we're at and this is where we need to be, and how do we get there? So another thing we can calculate here is what is their maximum profit that they could earn. So if they did the full 10,000 units, maybe that's their factory's capacity, what would be their bottom line in that scenario? So that's another thing that's beneficial to look at. So I talk about two more topics. One is operating leverage. So it measures the relationship between a company's contribution margin and their income from operations. So some companies have a very high contribution margin and fairly low fixed cost, and some companies have the other kind of relationship where they have low variable cost but high fixed cost. So I can calculate that leverage factor by dividing contribution margin by income from operations. So that I then can apply that in the formula to say the percentage change in income is going to be the percentage change in sales. Like if sales go up 10%, multiply that by the operating leverage, it'll tell me how much their income will go up. So here's an example of two companies. So the Jones company, you can see here, has an operating leverage of 5. They have a contribution margin of $100,000 and net income of $20,000. So the other company, Wilson, they have an operating leverage of 2. So if both companies had a 10% increase in sales, Jones is going to have a higher increase in income from operations than will Wilson. Okay, more is going to flow to the bottom line. The last thing I want to talk about is margin of safety. So margin of safety is essentially how far could we fall before we hit break even, okay? So we could calculate it in sales dollars. So that is, what are our current sales minus our sales at our break even point, okay? So I could come up with that dollar amount. I could do it in units by saying the sales minus sales at break even divided by a unit selling price. I could say, oh, we're selling 6,000 units now and our break even is 5,000, so we could not sell 1,000 units and still break even. Or I could do it as a percentage, where you can see I divide it by sales, and that tells me how far my sales could fall as a percentage and still break even. So that's an important concept. So that's the end of the lecture for chapter 21. If you have any questions, please don't hesitate to shoot me an email or give me a call. Thank you.